Okay, hi everyone. Let's take a look at this Black-Scholes model. It's problem 9-3. And I'll read it, the information up top, and then we'll go over some of the variables and then we'll solve it. Assume you have been given the following information on Purcell Industries. The current stock price is $15. Now I'm just reading to the left of my mouse here, okay? The time to maturity, 6 months. Variance of the stock return is 12%. D2 is 0 and ND2 is 50%. Now let's read what D1 and D2 stand for. Let's slide on down. Okay, so D1 is essentially a sophisticated mathematical problem, as you see as D1, and D2 then relies on D1 and adds a bit to it to the left of my mouse. But in real terms, n of d1, reading here, is the probability that a deviation less than d1 will occur in a standard normal distribution. Therefore, n of d1 and n of d2 represent areas under a standard normal distribution function. Okay, now we're not going to get too involved in the math, but we are going to use it to work with the Black-Scholes model. Okay, the strike price of the option is $15, the risk-free rate is 6%, and D1 is 0.24495. So someone's already worked through this fancy calculation to determine D1. And N of D1, again representing an area underneath the standard normal distribution function, is 0.59675. Okay, now let me slide. We just want to go over a couple other parameters that get used in the Black-Scholes model. V stands for the current value of the call option. In this case, that's what we're going to solve. P is the current price of the underlying stock, $15, given in this problem. We've already gone over what N of D1 is and N of D2, right? The strike price of the option was given, is 15. The natural log of E is equal to the number 2.7183, or I should just say, using natural logs, the value of E is 2.7183. R sub RF is the risk-free interest rate. T is the time until the option expires, and in our case, I think they've given us that, 6 months. And ln of P of X is the natural logarithm of P, the current price of the underlying stock, divided by the strike price. And then I believe that sigma squared is the variance of the rate of return on the stock. Okay. Now, I've gone ahead and solved this, but I want to illustrate how we solved it. Okay, we slide back up here. We're simply solving for expression 9-2. So V is equal to P times N of D1 minus X of the net of E raised to, and I know that's hard to read, but that's the risk-free rate raised to a negative risk-free rate taken times T times N of D2, right? So what I want to do is split those into the two terms. So the first terms will hit the F2 so you can see it. We take the value of P, which was the current stock price, $15, times N of D1, which was given as 0.59675, right above my mouse here. Okay, so that's a relatively simple term to calculate. Then we have to subtract out a more complex term. Let me show you how we do this. X is 15. We need to multiply it times E. E is given as 2.7183, and then we raise that to the value T, the negative value T. So we raise it to a power of 0.06. The risk-free rate was we raise it to the value of the risk-free rate taken times T. So the risk-free rate was 6% times 0.5, the time to maturity, right? That's the 6 months there, half a year. And then we multiply that times 0.5. Okay? And the way Excel does the terms really limits how many parentheses you need to add, but you could add parentheses to make sure the terms are done in the right order. In other words, it does the power first, so it takes e raised to the power, then multiplies it, and then multiplies it again. Okay? And when we do that correctly, the second half of the term comes up 7.28, and then we simply subtract the two. So we'd subtract the first term from the second one, and what we wind up with is the current value of the call option, which is $1.67, and that's the right answer. So let me actually put these into dollar signs, and we've solved this one. Thanks, everyone.